All right, pre-calculus. So as I promised, I was going to record a series of videos. I'm going to do 3 examples, and I'm going to do them in separate videos. So of what we were doing today in class of finding all of the roots given the actual beginning root. So we're going to work on this example here. So I have a polynomial. I notice all of the coefficients here are integers. It is to the 5th power, so I'm expecting that there be 5 roots to this polynomial, and we are given one of the roots already from the beginning, which is this complex number, -3 plus 3i. So, knowing that all the coefficients are integers, that means automatically that another root, since this is complex and it was given to me, that another root has to be that conjugate, that -3 minus 3i. So already 2 of my 5 roots are known. Now, in order to find the rest of these, I'm going to go ahead and, like we did in class today, I want to turn these into their factored forms, multiply it together to get a polynomial, which will then allow me to divide. So again, I can't just immediately divide these roots in here because these are complex. I gotta somehow turn them into reals, and by doing that, we're gonna carry out this multiplication. So first, we're gonna change this into factored form. So as we did today, so this would be x minus -3 plus 3i, and then finally x minus our -3 minus 3i. So as I did today, we're going to take those and multiply them together. So x plus 3 plus 3i, actually not plus, minus. So minus. And then over here, x plus 3 plus 3i. We're going to multiply those together. And I already know, once I finish my multiplying, there should be no more i's left because I'm multiplying the conjugates together. So we learned that from the last section, that that's always going to occur when we multiply conjugates together. X, 3, positive 3. We got x squared, 3x, negative 3ix, 3x, 9, negative 9i, 3ix, 9i, negative 9i. So we can see the ix's will cancel, the I terms will cancel. We're just left with this negative 9i squared. Remember that I squared is really -1. So this is really not a negative 9i squared, this is a positive 9. So altogether, what we end up getting here is x squared plus 6x, and then 9 plus 9 is 18. So there, as expected, nice polynomial, no more i's in there. So that will now allow me to divide moving forward. So when they're like this, can't do any sort of dividing with those because they're imaginary. But now that it's in this form, we can proceed with division. So remember, I cannot at this point anymore do synthetic division because this is a power bigger than 1. We're going to have to do long division. So I'm setting up my long division here. So let me just copy this over on this side. And I'm going to copy over my polynomial down here. So here's where you want to make sure, take your time when you're copying it over, because any little mistake here could mess us up. So starting here, this would be x cubed. So x to the 5th plus 6x to the 4th plus 18x cubed. Correct? So x to the 5th will cancel. 11 minus 6, so that's a 5. 46 minus 18. So that's going to be 28 x cubed. And then the rest of these will come down. And now we'll keep going. So now we want a 5x squared. 5 times 6, so that's 30x cubed. 5 times 18, so it's 90. Plus 9x squared. All right, and we will subtract yet again. So these go. 28 minus a 30, that's a negative 2x cubed. 68 minus a 90, so that's going to be 22, a negative 22 x squared. And then a negative 96, negative. Keep going, so minus 2x. And that's negative 12 squared. And negative 36x. You kind of see here, I'm not really thinking too much about this. I'm just kind of, at this point, and this is where you do enough of these, you just are kind of going through the motions. We know why we're doing this. It's just, I just got to get it so that I can get that reduced polynomial that hopefully I can factor or be able to put into a quadratic formula moving forward. So this minus a negative 12, so that's really adding 12. So this is going to be a negative 10. And then we have negative 96 plus 36, so that's a negative 60, and negative 180. So now the last part is, okay, I'm going to multiply everything by a negative 10. So that's going to line up perfectly as expected, because we know that since this polynomial, what we were dividing by, this quadratic, was made up of the roots, it should end up giving me a remainder of 0. Everything should cancel out perfectly. So now I'm left with this. Okay, so I divided. Now I'm left with this. So x cubed minus, plus 5, oops, do that again, plus 5x squared minus 2x minus 10. So now I have this, and I want to try to solve that. So hopefully you can see we can solve this one by factoring. I can factor by grouping. So we'll do that. So this is going to take out x squared. That's x plus 5. And in the second group, I'll factor out 2, leaving me with an x plus 5. So now I have x plus 5, and then x squared minus 2. So I can see one of my other roots is negative 5. I'm going to put my other roots here, negative 5. And then the other two roots is me solving this. So when is this equal to 0? Well, I can move the 2 over. And then I take the square root. So you see, oh, the other two roots, positive square root of 2 and negative square root of 2. So as I mentioned today, it's not only just the imaginary roots that show up as a conjugate pair, it's also the irrational roots show up as a conjugate pair. So sometimes we might be given as an irrational root. Understand that it's going to do the same behavior, as we can see here. Now, one thing that I didn't do in today's class is, what if they just ask me for writing it in a factored form? So my final factored form for this polynomial would be, and I'm going to erase all this here so we get some space. My final factored form, and you'll be asked to do this sometimes in the problem set, would be this times that x plus 5, and then times that x squared minus 2. So this would be, if I were to factor this polynomial, this is what it would look like. So know that this part here includes your 2 roots, and this part here includes these 2 roots. And then this one up here was the -5. So you see your 5 roots are made up in here. I write it like this as opposed to like this, because as you can see, that's a little messier to leave it like that. It's cleaner just like this. Same thing with this. Like instead of writing x minus square root of 2, x plus square root of 2, you'll leave it like this because we cannot technically factor it anymore. Okay, if it can be factored, we do that. So if this is at x squared minus 9, I do expect you to keep factoring and do that. But if it's something like this, okay, square root of 2 is not a nice perfect square, I cannot do this, so it will stay in that form. Same thing goes with that. That's why we also want to multiply those together to get that nice factored form. So this would be our final factored f of x. So sometimes you might just be asked only to factor, not to actually find the roots, but just factor the thing out. This would be it. All right, so that does it for our first example, and I will be again putting out a couple more just like these, so we'll do another couple of examples of this and look to those videos.